Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LGIT. Earlier lecture, we are already discussed about the system of non-homogeneous linear equations. Today's session, we are going to discuss about the system of homogeneous linear equations. Let's start. System of homogeneous linear equations, a system of m homogeneous linear equations in n variables like as x1, x2, x3 up to xn, or simply a linear system is a set of m linear equations in each in n variables that can be represented by a11 x1 plus a12 x2 plus and so on a1 and xn equal to 0. In second equation, which is a21 x1 plus a22 x2 plus a23 x3 up to a2n xn equal to 0. Continuing this manner, we can return in nth equation, which is am1 x1 plus am2 x2 up to amn xn equal to 0. Here is equal to something 0, that is our homogeneous linear equation, or is our linear equation x plus y plus z equal to 9, 2x plus 2y plus 2z equal to 3 or minus 1, so is equal to something constant value that can be indicated by the non-homogeneous linear equation, or x plus y plus z equal to 0, x1 plus x2 plus x3 is equal to 0 form, that is called the homogeneous linear equation. And this linear system, which is written in form of matrices, which is Ax equal to 0, where capital A equal to A11, A12, A13 up to A1n, A21, A22, A23 up to A2n. Continuing this manner, mth row, which is AM1, AM2 up to AMN, is called the coefficient matrices of the order m cross n. In this matrices, substituting this coefficient of x, y, z, or x1, x2, x3 up to and so on. Now let's see. Capital X is a x1 plus x2, x3 up to xn. That is the variables in a column matrices. Is any vector of the order n cross 1, and O indicated by the 0 column vector. Each and every elements of that column, that is 0, 0 up to 0, is a null vector of the order m cross 1. Now let's see solution of the system of linear equations. For a system m linear equations in n unknowns, means x, y, z, or x1, x2, x3 and so on, there are basically two possibilities of the solution of the system. First one is a system has a unique solution. That means it has exactly one solution. If it is unique solution, then each and every unknowns has a same answer. That means x1 equal to 0, x2 equal to 0, x3 equal to 0, x4 equal to 0 up to xn equal to 0. Or it is also called the trivial solution. Another solution, that is system has a infinite solution or infinitely many solution, or it is called the non-trivial solution. If system has a non-homogeneous system, then it has total 3 solution, and homogeneous system it has total 2 solution. In non-homogeneous system has a unique solution, infinite many solution and no solution, or it is also called the consistent and inconsistent. Here if homogeneous system, then it has basically 2 solution, unique solution or exactly one solution, or we can say that infinite many solution. That means trivial solution and non-trivial solution. If the system of the equations has a non-trivial solution, then with the help of determinant we can find it. If determinant of A equal to 0, then system has non-trivial solution. If determinant of A not equal to 0, then we can say that it is trivial solution. When the system of the linear equations has one or more than one solution, then it is called the consistent, or it is trivial solution. Here it is homogeneous equation, then it is also called the trivial solution or it has a unique solution. The matrices of the in form of A oblique B, that is A11, A12, A13 up to A1n, where 0 in second row A21, A22, A23 up to A2n slash 0. Continuing this manner in last mth row, which is AM1, AM2 up to AMN slash 0, is called the augmented matrices of the given system of linear equation. To solve a system of linear equations or elementary row transformation are used to reduce the augmented matrices to the row equivalent form or a reduced row equivalent form. Reducing to the augmented matrices to the reduced row equivalent form, it is called the Gauss-Jordan method, or reducing the augmented matrices to the row equivalent form, it is called the Gauss elimination method, which is already discussed. In this particular example, we can apply Gauss elimination method or a Gauss-Jordan method as you like. These are the following steps to solve the Gauss-Jordan method for the given system of linear equation. In step 1, firstly, whatever the linear equation which is given, which is written in form of augmented matrices. Now, with the help of augmented matrices, applying the reduced row equivalent form of the augmented matrices by using elementary row transformation or elementary row operation. In this particular method, we can apply only row operation. In third step, write the corresponding linear system of equations from the reduced row equivalent form. Now, in fourth step, solve the corresponding linear system of the equation by the back substitution method. Let's see one example based on the homogeneous linear system. Solve the homogeneous system of a linear equation by the Gauss-Jordan method. Minus 2x1 plus x2 minus x3 equal to 0, x1 plus 2x2 plus 3x3 equal to 0, 3x1 plus x3 equal to 0. In this particular example, is equal to 0 means here total we have 3 unknowns, x1, x2 and x3, and each equation equal to 0. That means it is homogeneous linear equation. Firstly, whatever the linear equation which is given, which is written in form of matrices, the matrix form of the system is Ax equal to B. Then it will give you minus 2, 1, minus 1, 1, 2, 3, 3, 0, 1, where unknowns which is x1, x2 and x3, which is written in form of column x1, x2, x3 is equal to B. Here is equal to something, each and every equation has a 0, that is written in form of column, that is 0, 0, 0. Here our capital A, that is the coefficient of the x1, x2 and x3. Now converting these matrices in the augmented matrices of the system, that is minus 2, 1, minus 1, 1, 2, 3, 3, 0, 1, where 0, 0, 0. Reducing the augmented matrices to the reduced row equivalent form. For that, making the leading element 1 in first row. For that, interchanging the first and second row. That is R1, R2. That will give you 1, 2, 3, 0, minus 2, 1, minus 1, 0, 3, 0, 1, 0. Now, with the help of that leading element, making the bottom entries of that particular leading element of the 0. For that, applying the row operation which is R2 plus 2R1 and R3 minus 3R1. Our matrices becomes 1, 2, 3, 0, 0, 5, 5, 0, 0 minus 6 minus 8, 0. Now, making the second row as a leading 1, for that, divide by 5 to the second row. That will give you 1, 2, 3, 0, 0, 1, 1, 0, 0 minus 6 minus 8, 0. For the, with the help of that leading element, making the bottom entries of that leading to the 0. For that, applying the row operation which is R3 plus 6 R2, that will give you 1, 2, 3, 0, 0, 1, 1, 0, 0, 0 minus 2, 0. Now in third column or a third row, making the leading element 1, for that divide by third row to the minus 2. That means minus 1 half R3. that will give you 1 2 3 0 0 1 1 0 0 0 1 0. Now that is our actually row equivalent form. Now we have to reducing to the reduced row equivalent form. Then for that, starting with last column, in third column we have the leading element 1 and above the leading element making the 0. For that, applying the row operation which is R1 minus 3 R3 and R2 minus R3, that will give you 1 2 0 0 0 1 0 0 0 0 1 0. Now with the help of second leading element, that is 1, and making the entries of above that leading element to the 0, that is R1 minus 2R2, that will give you 1 0 0 0 0 1 0 0 0 0 1 0. That is our reduced row equivalent form. That is exactly we have to find. Now for that we have the system of equations which is x1 equal to 0, x2 equal to 0 and x3 equal to 0. Means each and every element has a 0. That means it is trivial solution, or we can say that system has a exactly one solution or it has a unique solution. Means system has a trivial solution. Means we have total 3 unknowns and we have total 3 leading elements. If leading element which is same as total unknowns, then it is called the unique solution or it is trivial solution. Let's see one more example. Solve the following homogeneous linear system by the Gauss-Jordan method. Minus x1 plus x3 plus 2x4 equal to 0, minus x1 plus x2 minus x4 equal to 0, minus x2 plus x3 plus 3x4 equal to 0, and fourth one which is x1 minus 2x2 plus x3 plus 4x4 equal to 0. Firstly, whatever the linear equation which is given, which is written in form of matrices, the Ax equal to B. That means minus 1 0 1 2, minus 1 1 0 minus 1 0 minus 1 1 3, 1 minus 2 1 4. That is our matrix A. That is the coefficient of the x1 x2 x3 and x4. Now x1 x2 x3 x4, that is in form of column form, that is capital X is equal to 0 0 0 0 in column form, that is our is equal to B or is equal to O. The augmented matrices of the system is A oblique B, that will give you minus 1 0 1 2 oblique 0 1 1 0 minus 1 oblique 0 0 minus 1 1 3 oblique 0 1 minus 2 1 4 oblique 0. Here you can apply oblique or gem or simply space as you like. Reducing to the this augmented matrices to the row equivalent form or a reduced row equivalent form. Let's see. First, making the first leading element to the 1. For that, interchanging the first and fourth row. That means R1 4. Then 1 minus 2 1 4 0 minus 1 1 0 minus 1 0 0 minus 1 1 3 0 minus 1 0 1 2 0. Now with the help of that leading element, making the bottom entries of that leading to the 0. For that, applying the row operation which is R2 plus R1 and R4 plus R1, that will give you 1 minus 2 1 4, 0 minus 1 1 3, 0 minus 1 1 3 and 0 minus 2 2 6. Now making the second row has a leading 1. For that, multiplying with minus 1 to the second row, that will give you minus 1 into R2. That means 1 minus 2 1 4, 0 1 minus 1 minus 3, 0 minus 1 1 3, 0 minus 2 2 6. And with the help of second leading element, making the bottom entries of that leading to the 0 with the help of row operation. Here we can apply R3 plus R2 and R4 plus 2R2. That will give you 1 minus 2 1 4, 0 1 minus 1 minus 3, 0 0 0 0 0 0 0 0. Now that is our row equivalent form. Now reducing to the row equivalent form, applying the operation in second column leading 1 and above the second leading to making the 0. For that, R1 plus 2R2, that will give you 1 0 minus 1 minus 2, 0 1 minus 1 minus 3, and third and fourth row has each and every elements 0. Now that is our reduced row equivalent form. Now Here we have total 4 unknowns, and in this reduced row echelon form we have the total only 2 leading elements, means which is less than number of unknowns. That means it is infinite solution. That means our system has an infinite solution. Then in first and second column has a leading 1, and third and fourth column does not have a leading element. That means in third and fourth column are the free variables, means assuming the another variable in third column element and fourth column element. Now let's see, for the system of equations, the corresponding system of the equations is given by x1 minus x3 minus 2x4 equal to 0, and another one is x2 minus x3 minus 3x4 equal to 0. Here for this simplification, our equations becomes x1 equal to x3 plus 2x4 and x2 equal to x3 plus 3x4. Now in this particular example, we have the total 2 leading elements. That means, and we have total 4 variables. That means we have first and second column has a leading 1, and third and fourth column does not have leading ones. Means x3 and x4 are the free variables that assign another variables for the x3 and x4. That means assuming x3 equal to k1 and x4 equal to k2, where k1 k2 belongs to R, or k1 and k2 has any arbitrary constant. Now substituting the values of x3 and x4 in our system of linear equation and solving it, and then we get the values of x1 and x2. Then here x1 equal to k1 plus 2k2 and x2 equal to k1 plus 3k2, where k1 and k2 has any arbitrary constant. Therefore our system has an infinite solution. These all are the practice examples, which is try yourself. These examples you can apply Gauss elimination method as well as Gauss Jordan method. This is all about the topics of the homogeneous linear equations. I hope you guys learned something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.